Hello everyone, this is the temperature section of the measurement stations, and I'd like to review what temperature is. So as you can see right here, temperature is the measure of the average kinetic energy of each individual particle in a substance. So average kinetic energy. Remember, the kinetic is the energy of movement. So as the particles move around, they bounce into each other. They bump off the edges of their container. And what we do is we take a thermometer and we stick that into a substance, whether it's liquid or gas. You can even attach a thermometer to a solid, and you can measure the average kinetic energy of the particles with the thermometer. And what it does is, as the particles bump around and bump into the thermometer, they transfer some of that kinetic energy to the thermometer, and it measures how much is there. So what we think of as temperature, or what we think of as heat, is really just particle motion. And the faster something moves, the hotter it is, the more temperature it can transfer to the thermometer. So really, the faster the particles are moving, the faster the thermometer gets hit by all those particles, and the higher the temperature reading of the thermometer. So since it's a measure of the average kinetic energy of each particle within an object, you can also think about this in terms of the differences between hot and cold. If you look at the chocolate milk here, you can see that its particles are moving relatively slowly, and then see the size of their tail tells you that it's not moving very quickly. However, the hot chocolate on the right, these particles are moving very quickly, so that because they move faster, they bump into your thermometer more, and they transfer more energy, and the temperature reads higher. If I were to heat the chocolate milk, the particles would move faster, their kinetic energy would increase, and the temperature of the milk would rise. Now, we've got three different temperature scales. Fahrenheit, which is the one we use in the US, Celsius, which is used commonly in Europe and in England and in many other parts of the world, and what we use in science, and in fact what the SI units for temperature are degrees Kelvin. Now, I want you to take a look at this chart, and you can see some really important numbers here, things that happen regularly for us here on Earth. An important temperature is when water freezes. We're used to 32 degrees here in the United States, but in the Celsius scale, it's 0 degrees. Same thing with water. We're used to 212 degrees, but in Celsius, it's 100 degrees. Now, I want you to take a look closely at the difference between Kelvin and Celsius. You'll see that when water freezes at 0, absolute 0, the point at which all particle motion stops is negative 273 degrees. And take a look now at Kelvin. The temperature at which water freezes is 273 degrees, and absolute 0 is 0. So there's no difference in the amount of energy that we're measuring. It's just where the numbers are set. So for us in standard life, outside of the science classroom, it's easy to think about water freezing at 0. But scientists use degrees Kelvin because it's a more accurate way. That way it starts at 0 where there's no motion and just continues higher and higher and higher. If you are going to convert between Celsius, Fahrenheit, and Kelvin, I've got some of the formulas on the board. Number 1 here is if you would like to convert from Fahrenheit to Celsius, you would use this formula. So you would take the temperature in degrees Fahrenheit, you would subtract 32 degrees, and then you would multiply that all by 5/9, and you would get degrees Celsius. If you're going the other direction, and you want to go from Celsius to Fahrenheit, you use formula number 2, in which you would take your measurement in Celsius, you would multiply it by 9/5, and then add 32 degrees. You'd get degrees Fahrenheit. Finally, mathematically, the relationship between Celsius and Kelvin is here in number 3. If you had a temperature in degrees Celsius and you wanted to find degrees Kelvin, all you would need to do is subtract 273.15 to convert from Celsius to Kelvin. Finally, the idea of thermal energy. It is the total energy of the particles that make up an object. So the more particles you have in a substance, the higher the thermal energy it has. And here's a good example. You've got 2 liters of hot chocolate here on the left and 0.15 liters on the right. They are both at 75 degrees Celsius. However, the 2 liters has more thermal energy than the 0.15 liters because there are simply more particles. They're both at the same temperature, so therefore the object that has more particles will have more thermal energy.